Okay, here we go. This is Chapter 2, Lesson 3, book page 95 in the math book. Write each product, that's like a multiplication answer, using an exponent. Those are those little numbers that go up, so you need to know that. Okay, if you had 10 times 10, they don't really want to know what the answer is. They want to know how would you write it with an exponent. Your base number is 10, the big number, so write a large 10, that's your base. And 10 is being multiplied 2 times, so you put a 2 as your exponent. We know in science, as mathematicians, that if you have a small 2 up there, the exponent of 2, you're multiplying that larger number across 2 times. Once, twice. Okay? 8 times 8 times 8 times 8. I see a lot of 8s. That's my base number. It's being multiplied 1, 2, 3, 4 times, so I'll put my exponent as a 4. Mathematicians and scientists know that means there are 8's being multiplied 4 times across, like by itself. 8 times 8 times 8 times 8, 4 times. 1, 2, 3, 4. Got it. Let's keep going. This is a 3. I know that's the base number. 1, 2, 3, 4, 5, 6. 6 times across. 3 to the 6th power is equal to this as math, if you write it out. And that will help you work it out. Wow, 5 is the base number. 5's being multiplied 1, 2, 3, 4, 5 times. Wow, 5 to the 5th power. Mathematicians know what that means. Moving on, 9 is the base number. That's the number being multiplied. How many times? 1, 2, 3, 4. 4 to the 4th power. 9 to the 4th power means 4 9's being multiplied together. You'd have to work that out to find out what that actually equals. Moving on. 1 is the base number. That's the number being multiplied. How many times? 1, 2, 3, 4, 5. 5 times. 1 to the 5th power. Okay, that's how you write numbers as exponents. The number being multiplied and how many times it's being multiplied out is the exponent. The base number is the actual number doing the multiplying across. Write each power as a product of the same factor, meaning product means your multiplication, answer. So we have to extend this out into multiplying and then find the value also. Whew, here we go. This means the base is 10, and I'm going to multiply it out, 4 of them, 4 10s. 10, 10, 10, 10. I wrote it out 4 times. I'm going to put my multiplication symbol in there, and then I'm going to do the work. You know there's a trick though. You can just do a 1 with that many zeros. 1, 2, 3, 4. 1, 2, 3, 4. You learned that in class. It would be a 1 with 4 zeros. But to prove it to you, I will do this once. 10 times 10 is 100. Take that number times the next 10. 100 times 10 is 1,000. Take that times the last 10 times another 10, and it would be equal to 10,000. It's a lot of thinking when you can just put a 1 with 4 zeros. 1, 2, 3, 4 zeros. But it means the same thing. It looks a little sloppy. 10,000. Okay, this is 3 to the 2nd power. That means 3 is being multiplied 2 times. And I can put my multiplication sign in there. 3 times 3 is, hopefully you know, 9. That's done. That's easy. 9 to the, I think that's a 3rd power, or cubed we call it. This one is squared. We learned 2 is squared, if you remember that, squared. Because someday you're going to do length times width, and there's 2 things being multiplied, and that's why we call it squared, like length times width of a square. This one, anything to the 3rd power is called cubed. And the reason that's true, you'll learn in the future, is if you had a cube and you're actually multiplying the length times the width times the height, it's kind of sloppy, I don't feel like finishing it very much, you would have length times width times height, 3 things being multiplied. That's why anything to the 3rd power is called cubed, because that's what it takes to get the area of a cube. Anyway, let's just do the math. This is 9, because that's your base number, multiplied out 3 times. If I didn't want to do a time symbol, I'm allowed to put little dots, like dots like that, because that means multiply. So 9 times 9 times 9. Wow, what does that equal? Let's figure it out. Oh boy. Yep, I got the value. Okay, I know in my head that 9 times 9 makes 81. And then I need to multiply that by the last 9. So 81 times 9. I would have to do the math on the side because I can't do that in my head. 9 times 1 is 9. 9 times 8 is 72. Put down the 2, put down the 7. The final value of 9 times 9 times 9, or 9 to the third power, 9 cubed, is 729. That's the value. And that should do it. Okay, we've got Chapter 2, Lesson 4. This should be the last one before your test. Find each product mentally. They'd like you to do this in your head, but you have to know some strategies. So in my head, I would think to myself, there's a 1 in the front of this number, and there's a 13. That number is supposed to be 1,000. It's different than what I see written here. Sorry, I looked in the book. So it's 1,000 times 13. 1 times 13 is 13. That's the thing I do in my head. And there's 1, 2, 3 zeros after the 1,000 or in the thousands. So 1,000 has 3 zeros. Therefore, 1 times 3 is 13 with 3 zeros. And once I write that on paper, I can see that that's equal to 13,000. And hopefully you could pretty much do that in your head. Moving on. You have to know what this means in order to do it in your head. But once you do, it's not so hard. 37 times 10 to the second power, or 10 squared, is like 100. Do you remember working that out in the last lesson? 2 zeros, which is also the same as 10 times 10 is 100, because there's 2 of them, 10 2 times. What's 37 times 1? 37 with 2 zeros after it. So your final answer ends up being 3,700. Excuse me. This looks fairly easy. If you know your facts, you would know what 3 times 9 is. You always do the front end digits in the threes. If you can see this, 3 times 9. 3 times 9 is 27. 9 times 3, 27. So your answer is 27. And how many zeros? 1, 2, 3, 3 zeros. So that's how you do it in your head. Hopefully you get that. These ones are just a little trickier. This will be the last one. This is like saying 8 times 10 times 10 times 10. But you have learned a trick for this. 10 to the third power has 1, 2, 3 zeros in it. So that is equal to 1, 2, 3 zeros, 1,000. This is equal to 1,000 because it means the same thing as this. 10 times 10 times 10. Just multiply the front digit. 1 times 8 is 8. That's easy. And add the remaining zeros. 1, 2, 3. 1, 2, 3. Put your comma in. That is equal to 8,000. Let's try the bottom. Oh boy. This is 10 to the fourth power. So there must have been, there's 4 zeros. And let's see, 1, 2, 3, 4 zeros are in our answer. So this is a single digit. What times this 10 would put a 7 in the front? That's sort of easy. This is just a 1. So the missing digit is 7. Find the missing number, 7, because 7 times 1 is 7, and the 4 here tells us to have 4 zeros. 10 to the fourth power is like that, 4 zeros. So 70,000 ended up being your final answer for that one. And we'll do one more. How about this one? 10 to the second power means it's equal to 100 because there's 2 zeros. 10 to the second power is the same thing as 10 times 10, which made 100, 2 zeros. What would be in the front? Ooh, you have to actually think a little. What would be in the front that would make this 44 or 4,400 or 44 I'm looking at? What times 1 would give you 44 in the front? Ding, ding, ding. The missing number must be 44. Let's check it. 44 times 1, I'm going to write it down here, is 44 with 2 zeros. Does it look like that? Yes, it does. Therefore, 44 was the missing digit, or number, I should say, and your final answer was 44. 44 times 10 to the second power, 10 squared, is 4,400, or you could say 4,400. Thank you. Good luck on the test.